data loading is probably the biggest hurdle for every framework. So like for every web app, that's the thing that you have to worry about. If a framework can help you nail down the data loading pattern, that's a good framework.
Hello, welcome to devtools-fm. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey everyone, we're really excited to have Paolo on with us. So you're one of the Svelte team members, kind of working a lot in that area. It's been a while since we've talked to anyone working on Svelte. We had Rich on a long time ago. It's been really a long time ago now. So excited to hear how things have changed and what you are cooking up. But before we dive into that, I'd love to hear a little bit more about yourself.
Yeah, I'm Paolo. I come from Italy, as the name might suggest. Specifically, I come from Campobasso, which is a very small city in Italy that almost no one knows, even in Italy. Like they jokingly say that Molisente, like Molise is my region, and they jokingly say that Molisente, that we don't exist because we are very small. I work I lead the Svelte team basically at Main Matter, which is the company that employs me. We are basically a consultancy. We do basically a lot of Svelte, Rust, Ember. We are like a high-end consultancy in the sense that we are not just like there to like do feature development. We also do that sometimes, but we mostly help you like even hire. Like if you don't know how to hire, we can help you hire. We do what's called team augmentation. So we basically like join your team, like we work literally with you. We help you make your code base better so that we can leave and you can maintain your code base in a better state.
So is that what led you to being a Svelte maintainer? Was Svelte like one of those tools you reached for in those situations?
It's actually kind of the opposite, like in the sense that I actually found out this job because I love Svelte. So like they had a listing for a Svelte developer, and I actually discovered Svelte. I was in line for my COVID shot, so like in 2020, um, and so I discovered Svelte actually kind of late in the sense that like when it started gaining popularity with Svelte 3. So like I still remember, I'm a huge nerd. So like when I in my free time I usually watch conference talks and stuff like that. So I was watching the conference talk Rethinking Reactivity from Rich, and like the moment he mentioned the fact that like you can have a compiler do the work at the build time for you, my mind was blown, and I said like, why nobody else was thinking about this? And so like I decided to give Svelte a try. I used it for some side projects, and I really liked it. And so then I participated in the Svelte hackathon with Svelte Lab, which is like a REPL to build Svelte Git application, and we won. And so like I basically started to be always more involved inside the Svelte ecosystem. And at this point, I usually joke the fact that like if it has the word Svelte in it, I'm probably involved in some way. So like for example, I built the Svelte feed for the Blue Sky, like the Blue Sky feeds. Like I try to be as much helpful as possible whenever I'm in a community. And so I saw the listing for this job, and I said, "Yeah, that's my job." Also because like it was a very interesting job. Um, we at Red Matter we also do a lot of open source. Like we have basically 20% of our time we can dedicate it to open source because we love to give back to the ecosystem that we thrive on. So like we build the libraries, we build like even just blog posts like educational stuff and stuff like that. So like that was also one of the most interesting bit for me, and so I decided to apply. And then, yeah, I basically just being inside the Svelte community. Um, I was a Svelte ambassador before, which is basically a small circle of people that just talk about Svelte all the time. And like the Svelte ambassador is basically the inner circle, so like it's the first line of defense against a bad API, basically, because whenever we came up with with some API, we tend to like give this API to the Svelte ambassadors so that they can like try out and obviously like get feedback. And so when I was the Svelte ambassador, I got an early access to the Svelte 5 and runes, reactivity, and stuff like that. And I was I in the past I built for fun a small signal-based reactivity system, and so I said, you know what, I maybe can try to contribute a bit, and I started contributing, and like as usual, like I'm very deep on open source, like I love to contribute, and so I started contributing more and more and more and more, and then in the end, they almost had to like they say, okay, I really don't want because you suck. No, I'm joking. I don't think I hope they don't think that about me. But like, yeah, they invited me to be a maintainer, which obviously I said I'm more than honored.
That's an awesome story. Uh, I am always struck how many like open source stories are very similar and like often just very interest driven, and you like get involved with the community and like start doing more and more, and then like before you know it, you're helping maintain. So it'd be great to talk a little bit about Svelte 5. I mean, Svelte's seen a lot of changes over its life. I mean, we're on 5. That's a pretty large amount of like major versions, and I think it like really reflects the learning and the iteration in the space. And like the thing that I've really always admired about Rich is like his capacity to sort of like learn from what other framework authors are doing and sort of like incorporate the best of that into Svelte while still having a very opinionated core. And so Svelte 5 introduced this notion of runes, and it was a pretty big effort to get it shipped. So yeah, just tell us a little bit more about that. Like, what's new in Svelte 5? What's this rune thing all about? And maybe walk us through some of that journey.
Yeah, Svelte 5 was released basically like I think almost 1 year and a half, more or less, and it was a substantial rewrite of the whole compiler logic, the whole like even the runtime logic, because Svelte 4 was more like all the reactivity was at compile time. There was obviously a very small runtime, which was mostly like helper's method to create an element, to like get an element, to set the text of an element. But like this was just basically to avoid that extra boilerplate of writing to the component. But all the reactivity was mostly done at compile time. However, like during the years of use, like there were some limitation about the compile time reactivity. Obviously, they were not like very big limitation, but there were some limitation, especially when you reached a certain level. Like bigger code bases was like kind of difficult to work with reactivity. There was also another problem, which was that you couldn't use the compile time reactivity in a TypeScript file, because obviously, like on a Svelte file, we can act easily. On a TypeScript file, you can't really interject like in between of the actual TypeScript compiler. So like it was problematic in that sense. Also because, for example, for our reactive, like a label statement, we use like the label, which is an actual syntax in JavaScript. So that was like a very nice thing. Like it was very short, very nice, very easy to remember. But also like you could not type that with TypeScript. If you wanted to put that inside a TypeScript file, that was problematic and stuff like that. So like uh, we, and I mean mostly them, like I joined kind of late in the sprint towards Svelte 5. So like I gave some feedback as an ambassador, and then I contributed a bit during the last straw of the sprint. But obviously, the rest of the team did the actual big work, and like they went along like a lot of iteration on what can we do to make this work even outside Svelte compiler. Can signals, which is like something that was popularized by Solid, and like basically every framework except React now has in some way. Like, can signal help with the runtime part that we want to have? And in the end, it turned out that yes, it can help. And so basically, like, it was a pretty big rewrite. Technically, like, you could have with the signal-based reactivity, you could have the same syntax as before, because like effectively you can use the same syntax as before in .5 in a legacy component. But we explicitly said, okay, like, we can make it better. Like, we can change some stuff that might feel a bit weird initially. Like, if you approach it knowing Svelte 4, it is a bit weird in the sense that, like, in Svelte 4, you had just let x is equal to 0, and that was it. And now you had to have $state, which maybe I don't want. Like, the very initial gut response from everybody, like even myself, like as soon as I saw it, I said, I don't know if I like this, because like, now I have to annotate this. But then, like, the more you spend time with it, the more natural it feels, first thing first. And then the more you realize how much better it is, because it's a silly thing, for example, but with runes, you can actually have a variable that is not reactive. So it's not always that you need it, but when you do need it, it's a very nice optimization. And so, like, it's everything, it's more explicit, everything is more like mature, I would say. So, like, it's a thing that, like, helps you, like, write better code, even read better code. So yeah.
So it's been a while since then. There was initially some like objections to the syntax. Do you think it's shaken out well in the end? Do you think think the simpler model has merits, or like there really should have been this from the start?
Yeah, like the usual like discourse whenever you present Svelte 5 to someone, if it is new to Svelte, they just like it as usual, because at the end of the day, if you take a look at like the amount of changes that you have to make from a Svelte 4 component, they are very minimal. Like, it's mostly at the declaration side. So instead of declare let x is equal to 0, you need to declare let x is equal $state to 0. Mm-hmm. Instead of doing colon, like $ label, $colon, xx is equal x plus times 2, you have to do const xx is equal $derived x times 2. So, like, there's not a huge amount of changes. So people that were very used to Svelte 4, initially, like, the first thing, it was like, oh, I don't like this. And then they tried it for 1 week and they say, oh, I love it. It's like, that was the usual arc that I myself went through. But it was the usual arc. Like, you start using it and it feels different from Svelte 4. And so there is an initial friction. But then when you start using it, you realize that it doesn't change too much. And then you realize, like, how much possibilities it actually opens up. So even just the fact that you can now use reactivity, the same reactivity outside of a Svelte component in a TypeScript file, that's already like a huge win. And in terms of like runtime reactivity, that allows you to have like deep automatic tracking. So you can read something inside a function, and that something actually became a dependency of an effect, for example. That's just wonderful. Like, it's something that you could have not done before. So you had to like resort to some kind of tricks. So, like, if you have some utility function in Svelte 4, you always had to accept the reactive variables inside that utility function, because otherwise the compiler was not able to see inside the function. And so right now that's not a problem anymore. So like there was a lot of small cuts, you can say, that were fixed by Svelte 5. And so usually like you see it and you like it's different from what you already know, and there's a bit of friction, and then you start to using it and everything goes away because it's just so much better to use. And it's also much, much faster.
I think my favorite part about it is it's like so much more explicit. It's like easy to say, okay, this thing starts with a $, it's reactive. The inline syntax, the like $:, the label syntax that was in Svelte before was like, you know, it's like a reappropriation of syntax, and it's kind of magic. And like I remember like people like being like, oh, what is this? And like, how does this work? And like kind of, you know, having some like questions about it. And then it's like, yeah, you know, it works pretty well. But like always had this problem with it is like, there's like this discoverability problem, and like you really have to keep track of like, okay, what's reactive and where is it reactive, whatever. And I think there's this like mental overhead. So I think this like hits that sweet spot of like still giving you the ability to make things reactive, but like making it very explicit without being overly verbose. It's pretty nice. Another big change that y'all did last year was introducing like async sveltes and remote functions. I'd love to hear a little bit more about that. What was the sort of like motivator for that, and how has it changed things?
Yeah, I mean, the main motivator is actually that obviously I think like data loading is probably the biggest hurdle for every framework. So like for every web app, I would say like that's the thing that you have to worry about. So like if a framework can help you nails down the data loading pattern, that's a good framework. And so we started exploring like how can we do that, like what would be the ideal API. And this is something that like we always do when we start like theorizing about some API. And I think one of the superpower that Svelte has is that being a compiler, we can most of the time do this. Like we can just say, okay, what would be the ideal API? And then we work backward from there, and we say, okay, how do we make this happen with the compiler, and what kinds of stuff we have to do to make it happen. And so the ideal world would be that inside your component you can just await things. So we said, okay, can we do it? And we worked backward from there. So and I think, and again, I say we, in this case, I was involved like during the meetings for figuring out the API, and we gave like obviously each one made our like we make our parts, but obviously like Dominic was Rich, Dominic, and Simon were like working full time on it, and obviously like the moment you can work full time on a project, you have a much bigger impact. So they did a lot of the work, and I would say that it turned out wonderfully. Like we have to do a bit of compiler magic to make it work, because especially with signals, like it's very easy. Like I don't know if you ever used another signal-based reactivity system. You know that the moment you await something, you've lost your reactivity, because the way signal works is that more or less like basically whenever you read something inside an effect or inside a template effect and stuff like that, the signal is basically keeping track of, okay, now I am inside this effect. So you know that you are inside this effect, and so you store that effect in your list of subscribers. And that basically can't work the moment await is involved, because the moment you await something, a function that you are in is basically like cleaned up before you read a value from a signal. And so we had to do basically like some sort of, okay, before every await, we store every information, every context, like the context that you are in right now. And then after the await, we restore that thing. But obviously, all of this it's in a huge machine that is the whole system. So like you have to keep track of. What happens, for example, if while I'm changing some value, and this triggers an await, an asynchronous reactivity pattern. What happens if I change that value again? And what happens if I change another value again? So there's all these branches that goes from with the moment you introduce asynchronicity in your reactivity system. It's a huge deal, and so that's also why we released it as experimental, because obviously we wanted to get feedback from the users, because for this kind of stuff you gotta use it. There's no way, even if you are designing it, even if you're writing a huge test suite. I love the Svelte test suite because we have over 7K tests. So there's a lot of tests, and this absolutely saved my I don't know if I can use they absolutely saved my bottom part multiple times, because when you are making changes, especially in a web framework, you make some change and you don't even thought about that edge case, that it's only available in Safari, and it's messing these things up. So they saved a lot of time. But even if you have a huge test suite, and even if you plan to write a huge test suite, there's literally no way you can figure out every single possible way people are using that feature. And so the only way is that actually you need to put it out as experimental, and then people will report a bunch of bugs. And so that's exactly what we did. And so it's now under an experimental flag that right now it's mostly the main focus of Svelte. So we are ironing out the async and await stuff, so that hopefully we can remove it from experimental when Svelte 6 lands, which will be in a bit. So, but yeah, that's the main goal. And the moment we added this new pattern, basically, we also realized that we could have done something also on the SvelteKit side to make things much better. So and that's basically remote functions that are also an experimental feature right now in SvelteKit. And so right now in SvelteKit, basically when you have to load data, you have a separate file, and that's something that we care a lot about. This there are a lot of meta frameworks right now that basically allow you to load data within the component, but to load data within the component, you are kind of mixing client side and server side stuff, right? And so something that SvelteKit was always very keen on is the fact that server side needs to be there needs to be a file boundary between the client and the server, so that you can actually be sure that you're not leaking some stuff inadvertently. Even if they are in the same file, you can transform it to remove it, but then you either have to disable source map or expose the secrets. So that's not a good trade-off. And so we right now in SvelteKit, you have a plus page.server.ts file with a load function exported from it. Whenever you return from this load function, it's available as a prop of your plus page.svelte file. And that's nice, to be fair. It's not a bad pattern, but we realized that we could have done better with this new, especially with the new await expression syntax. And so that's where remote function comes in. So is an experimental flag once again, but with this experimental flag, what you can do is that you can have a .remote.ts file, and this file is executed on the server, basically. So you can export function from these files, and it's basically RPC. So you export file from these functions, and these files, on the clients, is a fetch call to an endpoint that gets created for you, and on the server is just literally invoking the function. We also obviously put in place a lot of I think the security aspect of this is very important, because obviously you are exporting a function, but in reality you are creating an endpoint which everybody can call. And so that's why, for example, we used standard schema so that you can bring your own validation library so that you can actually validate the stuff that you get. You cannot call, I think by default, you can't call a remote function from a domain that's a different origin from your origin. So like there's a lot of things that obviously gets into place because obviously you want to make sure that like not everybody can just invoke a function on your server. So yeah, that's also another like very nice enhancement for SvelteKit. And
Yeah.
I've been building with them a bit, and like it's really a good like I'm a Svelte guy. Like I love Svelte, but even more, I like what got me really hooked into Svelte was SvelteKit. Like I really,
Mhm.
when I like started looking into SvelteKit, I was impressed by the amount of care that Rich and the rest of the team put into SvelteKit. And with remote function, it's even like it's just almost magical. Like you just create a function, you await directly inside the template. Like it's so like it's everything so natural that it's just wonderful.
Yeah, I really like the remote functions. And there's this like, it's been kind of a big trend of, um, this back end for front end, like how can we make the integration between the server side and the client side like more seamless, like feel like you're working on one service, kind of abstract the distributed systems problem a little bit. Um, but we've also seen that like cause problems. Like there was the famous like React server component security vulnerability. I think there was a pass on. I know that Svelte had some similar but like different issues where like I think the security researchers in the space started realizing, hey, all these like full stack frameworks are like adding these implicit RPC interfaces, and these are like a security target. Post kind of all of that happening, I know you just talked about security. How are y'all feeling about how remote functions are landing out and how they're sort of like positioned, just like in this like more like security conscious time of thinking about these RPC like
Yeah, I mean, to
functions?
be fair, like it's always good to be fair when we receive some security vulnerability, which is actually like safely disclosed. So like the React debacle recently, like the React to shell, if I remember correctly, the name was a huge thing, but that also sprouted a bunch of like security researchers that said, okay, let me look at something similar in other frameworks. Now, that obviously sprouted a bunch of security vulnerability in every single framework. Uh, I would say, like, luckily, most of the security vulnerability that we got in Svelte were minor, respect of like, I mean, React to Shell was pretty bad because like you actually gained access to the server itself, like remote execution on the server. So like, but so we got some easier to like not only easier to fix, but also like way less powerful vulnerability, and that's actually good. Uh, Actually, recently, Vercel, which again it's paying for like Rich, uh, Simon to work on the and Elliot to work on Svelte full time. Vercel also published like a HackerOne campaign, so like you can actually get bug bounties to like report a security vulnerability for Svelte, and that actually like is paying off. Like we're getting some report. We are like fixing stuff obviously as soon as possible. So like I think it's paying off, and we ourselves like obviously are also looking into this thing with a keen eye, right? Okay, given that that thing happened, like let's check if we have something similar, or let's see if we can exploit remote function in some way. For the moment, it seems to be like secure.
So switching gears a little bit here, looking through what you've been working on lately. You've been working on MCP servers a lot. I have too. It's an interesting topic, and I kind of think is where a lot of the future lies. But can you fill us in on what TMCP is and like why you built it?
Yeah. So TMCP is another library that I started writing, and it's a library about building MCP servers. So my main issue, like the reason why I started writing it, it's because of Svelte, as usual, as most things in my life, they like they are derived from Svelte. But the point is that obviously we started looking into like as usual, whenever I start to look at something, like for example, a Blue Sky feed, the first thing that like do is okay, can I build this with VeltKit? And this for two reasons, but because I like building with VeltKit, and also because I want to see what's missing in VeltKit. So like if there's something that is missing in SvelteKit, I want to add that thing to SvelteKit so that you can also build, like users can also build stuff for that. And so when I started looking into how to implement an MCP server, I guess like if you search how to build an MCP server, like 99.9% of the stuff will recommend the Model Context Protocol / TypeScript SDK, which is the official SDK from the Model Context Protocol. So obviously everybody's recommending that. I have to say, like, it is getting way, way better. But when I started looking into it, it had several problems. Like the client and the server were all one single monolithic package. There was like an abundance of dependency that like there was AJV for parsing stuff, but they also had a hard dependency on Zod v3. So if you wanted to use Zod v4, you couldn't. They also had like some weird API, like for example, if you want to create a resource template, you have to use a class, but then if you want to use a normal template, you have to use a string. So like they had all this kind of a weird API, difficult to use because you had to do a lot of it yourself. It was also like using node request and node response instead of web request and web response. And so that was like kind of a big deal for SvelteKit because in SvelteKit we use fetch request and fetch response. Like it's more like using the platform like the modern platform. There were ways around it. Like for example, there was an adapter from Vercel that basically under the hood was like creating a fake node response and then writing all the information to a web response. But like it was a lot of extra work. And so when I started to look into how to create an MCP server, I said, okay, I can literally do this with like two sets just to keep track of my tools and like a JSON RPC stuff. And so I started building it even just for fun. And then like the more I looked into the official SDK, the more I said, I really want to build something. And so I started to building TMCP, which is basically a way lightweighter alternative to the official SDK. I would argue it's also like with some nicer API. Like I tried to design the API so that it's always expectable. Like in the sense that like if you are building, I don't know, if you're doing server.tool and then I do server.resource, I would expect more or less the same shape and not a completely different shape. If you use a class to generate the server, I would expect the class to generate the transport first. I don't know, there's a lot of stuff, and also I wanted to build something that was very very modular. So like if you are using the HTTP transport, you are not bound to also install the dependencies for the STDIO transport. And even worse, the opposite. Like if you are building an STDIO transport, you don't want to install Express like they were doing it. Now, as I've said, like the official SDK, it is getting better and better by the day because obviously there are a lot of people that are contributing to it. So obviously, like people have the same complaint that I have, and like when more people are complaining about some stuff, obviously like it will get fixed more like hopefully. I think TMCP is still a very good alternative, and I'm maintaining it a bit for fun because it also helps me keeping up to date with the MCP world, and also because I built the Svelte MCP server with it, so I like I'm attached to like I actually have a dependency on it, so like I want to make it better. It's also being used a bit like Storybook. It's using it for its own MCP servers. Like there's some people that are starting using it, so I'm happy about it.
While building it, was there anything like that you learned about MCP that kind of surprised you? Like when I was reading through your docs, like you call it out and I didn't even realize it, that like resources are a very particular and specific thing that aren't just like automatically injected into context. There's like very specific situations
Yeah.
where those get used.
Yeah. I mean, I learned a lot about the MCP protocol in general, which I also think like it has its own problems. So, for example, something that right now I'm working on the new version of the protocol because on November it was released, the new version of the protocol, and I support two or three things. Like there's something missing from the new version of the protocol in TMCP, and the reason it's missing is because I hate it. That's not like, but the point is like one of the things that I don't like about the protocol is that they're trying to make the protocol stateless, like it should be, in my opinion. But then there are a lot of stuff that are actually stateful. So like for example, like right now, tasks, which is a new thing that you can add to do async work easier, those are fully stateless. And that's a huge issue because I try to make stuff that can be served from a serverless platform, for example. So, like, if you want to have like some stateful, you need to hook it up to something like Redis or Postgres, and that adds a lot of complexity to the whole system. So yeah, and obviously, like in the meantime, I've also learned a lot of like about MCP in general. So, like for example, I don't think a lot of people are using the full potential of their MCP servers because uh, like most MCP servers are just, oh, is my tool and that's it. While you can have, for example, prompts are one of the best tools inside your MCP arsenals, in my opinion, because you can literally instruct the LLM on how to use your MCP server in a very easy and portable way. And for example, even a lot of clients don't support it because it's just like, yeah, I support tools. That's it. My personal client, like not my personal client, the client that I use for my work, which is open code, was not supporting it initially. And that was the reason why I couldn't switch to open code. Like I was using Cloud Code because I wanted to use my prompts. And then I said, wait a moment, I can just contribute to it. And so I contribute to open code, and now they have prompts. And so I switched to open code.
That's pretty cool. Are you using standard schema for the like schema input? We had the ValleyBot author on not too long ago, and I was like noticing that you do have like different packages like for the validation libraries, which is great. But I was wondering if like is standard schema making that easier?
Oh, absolutely, yeah. And that was one of the things that I didn't like about the official SDK, the fact that they didn't support standard schema. I wanted to support standard schema because I wanted for you to use the validation library that you already have. So like I love Valibot because it's smaller. I can use it on the client. It's tree shakeable and stuff like that. And if I'm building my application and I already have Valibot, I don't want to also have a dependency on Zod just because I'm building an MCP server next to my application. So like that was something that I really wanted to have. There's this small issue that is the fact that right now it's kind of solved by the fact that right now there's also a JSON schema, a standard JSON schema, which is like another spec basically, which is how that also tells you how to convert a Zod schema to JSON schema and a Valibot schema to JSON schema and stuff like that. So like it's basically another type library, and you can use that if you need to convert a schema to JSON schema. So I could use that if not for the fact that I don't like how Valibot did it, because in Valibot, if you want to do it, you need to install a separate package, and then that separate package is to JSON schema, and the user needs to manually convert to JSON schema, and that works both as a schema live validation and both as a so like I didn't like this thing, and so I'm sticking with my adapter pattern, which I like more, so that you can just install TMCP Valibot adapter and get everything from that. And yeah, but it's absolutely helping, and I love standard schema.
So you said that you created the official Svelte MCP server. I'm sure you had lots of iteration there, getting it to a place that worked for you guys. So like what's kind of like your design approach? What did you find worked? Is there anything like interesting or unique that you put in there?
I think I mean, not to brag, and also it was not just my work, but I think the Svelte MCP server is one of the best MCP server out there. And when I try to design an MCP server, I try to follow some rules, because a lot of people also say that MCP is bloated, and I use skills because MCP server is bloated. And that's partially true, but I think MCP server are bloated if you design them wrong. Because the point is, if you fill your MCP server with like 200 tools with like 30-line description, that will be bloated. So like when I try to design an MCP server, you need to think about the minimum amount of stuff that you need to make the LLM more capable. One of the very nice thing about the MCP server, the Svelte MCP server, is that, so Svelte has kind of a problem with AI, and that's the fact that the Svelte 5 migration introduced a lot of like syntax changes, and all the LLMs were trained on old data, on old Svelte 4 data, and so like older LLMs now is getting better, but older LLMs were struggling to produce Svelte 5 code. And so like the Svelte MCP server, it's a guide for that, because we have this Svelte autofixer tool, which is very clever in my opinion, because we don't fix the code for you. We just analyze the code that the LLM creates, and we give suggestions in natural language. So like the suggestion is actually a suggestion for the LLM, because we perform basically static analysis on your code, and we are good at that because we are a compiler. So like we have the abstract syntax tree that we can navigate and stuff like that. But syntax analysis can only get you as far as like there is a limit on how hard you can go on syntax analysis. But LLMs don't have that limit. Like if you return a sentence like, maybe this is not the right approach, but think about it, it will not just substitute like that approach 100% of the time. It will actually reason about, is this the good approach? And then decide if that's the right approach or not. And this, I think it's a very, like, for example, with this approach, the optimization of running your, like, I don't know if you know about code mode, which is the proposal from, I think Cloudflare came up with this. And that's a very interesting approach to MCP server, but that only works, in my opinion, if you didn't design your MCP server very good. Because the point is, for that to work, you need to design your MCP server in a way that it's more like code. Like it's more like if you're running a function or returning something to a developer, and not if you're returning that function to an LLM. So like if you think about the fact that you are returning information, you are returning context to an LLM, that's when, in my opinion, you are designing a good MCP server, when the response is not for code, is for the LLMs. Like you need to talk to the LLM even with the MCP server, in my opinion.
Yeah, that's pretty cool. I think it's an area that's still evolving and definitely needs a lot more attention for sure. But
Absolutely.
it's cool. I'll definitely want to check out your library because I've been working on an MCP server myself. Another thing I'd love to dig into is, so you've done some work around custom renders in Svelte, and this is like one of my favorite aspects of our new frameworks. So like React has for a while had like custom renders, and there's like libraries like React Ink to like let it render to a TUI. And I think this is like, such a fun abstraction to like let people use the tools that they're building for the web to build for other platforms. And so yeah, I'd love to hear a little bit more about your work around custom renders for Svelte and like what the state of that is and kind of what you think the future there would be.
So basically, this is actually something that like I'm very happy about. Like this is like circling back to my job, because as I've said at Main Matter, we love to give back to the ecosystem that we thrive on. Right? We are working with Svelte. We love to give back to the Svelte ecosystem, and so we had literally a moment when we said, okay, what can we give back to the Svelte ecosystem? And I started exploring a bit, and I realized that like there was this framework, Links, which just came out, which basically it's like an agnostic version of React Native. But to make it work, you have to have a custom renderer. And now, what is a custom renderer is an interesting question, and is basically what allows, as you said, a framework to render to something that is not HTML. So, for example, React has React custom. It has React native. Obviously, it has Ink to render to the terminal, for example. And so basically the reason why it works is because React only concerns itself with the diffing algorithm, more or less, and then is the renderer, like they have a separate package to render that virtual DOM to a tree, like to an HTML tree or to the terminal and stuff like that. Now, Svelte was always built basically to render to HTML. So like we didn't have, to be fair, like we don't have a custom renderer right now. And so since you needed a custom renderer to build a native app with links, and native application is also something that like a lot of clients, like they search for it. Like they say, okay, I want to build this application, but I also want to have a way to build a native app with it. And so I started exploring a bit links. We said, okay, maybe we can build the custom renderers. And so Main Matter actually sponsored me. Like I worked for basically 3 months full time on Svelte to try to build the Svelte custom renderers for Svelte. Now, obviously, like that's a huge thing to build. So like we actually built a POC for it, which I was very hyped. Like the moment I got to actually render some links element, and so I could actually see a native app built with Svelte, was like emotional. I built a simple to-do app because obviously you're gonna build a to-do app to demo something, and it worked. And so we launched basically the Svelte custom renderers initially. So like they sponsored me for those 3 months, but then we basically opened it for the community. So like we said, if you have the need for a Svelte native application, or even for something else, because I also built a custom renderer for the terminal, a very like cheap one, like it's not as advanced as Ink, because Ink is also using Yoga under the hood to do like layout and stuff like that. Like I built a very small terminal renderer, but like obviously you can render to everything. Like you can render to Canvas, for example. You can render to WebGL. You can render to like your own custom thing. You can even have, I don't know, a Svelte component that renders to string. Like you can build your own weird stuff, like, and you can build JavaScript with Svelte. So like it's a very powerful paradigm, I think. And so we launched this thing. So like, and by the way, if you're interested, you can go to svelte-custom-renderers .com just to read, to learn more about it. Or if you want to go to mainmatter.com, it's also linked from there. And we got it to a point, like obviously I was working with Rich and Dominic and Simon and the rest of the team to figure out the right API. So basically, the point that we are right now is that we have a pretty good idea of the API that we want. So, like as a small spoiler, what we want is that we want you probably to define, like, I mean, not you, like you will probably just install your own custom renderer. But if you want to create a custom renderer, you basically have to export from a module and create renderer function. Like you can do export default create renderer. And this create renderer function will basically accept as an object with a series of operations that Svelte needs to create something in your world. So like once you use your custom renderer, what we will do is that basically at compile time, we will import your module and we will give the custom renderer to the Svelte runtime. And so the Svelte runtime under the hood, instead of doing like document.createElement, it will do renderer.createElement. So like at the end of the day, basically we will call into your function. And so it's kind of up to you to define how you want to create your element in your world, because obviously we kind of need this to make it fully customizable, because Links knows how to create a links element. So like the only way for Svelte to create a links element is for Links, the creator of the links renderer, to determine how to create that. So again, this is basically what I have in my POC. We recently come back together because we had a bit of funding already. So I started working a bit more on this. And we came together once again with the maintainers to say, okay, let's see if, like with the updated async await stuff, like we need to rethink how we built this. I think, well, we slightly changed how it was gonna work, because initially what we thought was, well, we have basically two separate runtime, right? We have the client DOM runtime, and in the client DOM runtime, we are doing a bunch of weird tricks that you can just basically do because you are in the DOM. One of the very initial idea was we could try to basically, when you do create custom renderer, we create inside this function DOM, basically, and then we just invoke that DOM whenever we do stuff. The problem is that the DOM is weird, like very, very weird. Like there are so many quirks in the DOM that once you start trying stuff out, you start figuring out like, okay, for example, one of the tricks that we use inside Svelte is that if we want to empty a node completely, like remove every single node inside another node, you can just set text content is equal to empty string, and that will actually invoke the remove from every single DOM instead of looping over every children and removing it. So that small thing, obviously, we would have to build that weird quirk inside our DOM implementation, and we also had to keep it up to speed. Basically, like whenever there is a new quirk that is introduced because of a change in the DOM, we have to also include that quirk in our implementation of the DOM. So we discarded this information. We just like, okay, let's not follow this route. And so we moved to this other idea. But the problem is that we are still using this kind of tricks inside Svelte. And these tricks are one of the reasons why Svelte is fast. So like, if we just forego these tricks and we just literally remove every single node, that will make the experience worse for everybody that is not using a custom renderers. And so what we initially thought of doing was, okay, let's actually split the two runtimes so that if you are using a custom renderers, we import a completely different runtime, which is much more minimal because we don't have to care about hydration, because Obviously, hydration is something that only works when you are server-side rendering, and you cannot server-side render in the terminal or in a native application. And so we have these two separate words, basically. And the idea was, once we have those two completely separate words, when we are developing, we are aware in which word we are. So like we have literally two separate folders in the repo, so that if I'm making some change, I know that I can use some DOM trick or not, because obviously, like in that case, like it would be fine because I'm in the DOM runtime. Otherwise, I'm in the custom and I cannot use that. However, once I started implementing this runtime, we realized that there would be so much code that is literally copy pasted, and most importantly, like it would have to be like just slightly different from one another, and that would be a hell to maintain. So like right now, like in the phase we are right now is that we know the API, we know how we want to build it, and now what I'm trying to do, I'm building into one single runtime, which will be slightly different to maintain, in the sense that we need to find also a way to prevent ourselves to just access these. Like we probably need to write some lint rule for the Svelte code base, so that you can't actually just do text content is equal to empty string without checking if there is a custom renderer before. But otherwise, like it will be slightly different in that sense to maintain, but way better because we don't have to duplicate code.
Okay, so much interesting stuff. Yeah, custom renderers, that's a hill to climb right there. That wraps it up for our time and our questions on this week's episode. Thanks for coming on, Paolo. It was a lot of fun talking about all things Svelte and getting us caught up.
Yep, thank you for having me. And once again, just like to remind, in case, like if you want to join the custom renderer initiative, go to svelte-custom-renderers.com or visit springmatter.com. And obviously, if you have any issue or any like suggestions, feel free to reach out on Discord, Blue Sky for me.